3.2 factor and remainder theorem. We're also going to learn here division, polynomial division. There are two kinds of division. We're going to practice long division first. So we're going to divide the polynomial x to the third plus 4x squared minus 5x minus 14. We're dividing this by x minus 2. So long division of polynomials is just like we do long division of numbers. You write your divider. X minus 2 goes here, and we're dividing x to the third by x. So what times x will give you x to the third? X squared. So x squared times x is x to the third. X squared times negative 2, negative 2x squared. We subtract. The first one cancel. So pay attention, you're subtracting a negative number, so it becomes positive. So this is 6x squared, and we copy the other terms. And now we are asking ourselves, what times x will give us 6x squared? What that will be? Positive 6x. So 6x times x, we multiply back. 6x squared minus 12x. And subtract. The first one always cancel. Pay attention. We're subtracting a negative number, so become positive. So 12 minus 5 will be 7x minus 14. And last step, what times x will give us 7x plus 7? So 7x here again, minus 14. We're subtracting, and everything cancels, so the remainder is 0. That means x minus 2, let's make a note here. Remainder equals 0. So x minus 2 is a factor of the polynomial x to the third plus 4x squared minus 5x minus 14. We're going to use this information later when we state the remainder and the factor theorem. So another kind of division is called synthetic division. And we're going to do the same example, the same polynomial. So x to the third plus 4x squared minus 5x minus 14. We're dividing this by x minus 2. But this time, we're going to write the coefficient of your polynomial in order 1, 4, negative 4, and negative 14. If there is a missing term, in this case, there's no missing term because you have x to the third, x squared, x, and a constant. But if there is a missing term, let's say 4x squared wasn't here, then we would leave a space for that missing term. So this is how we start. We write the coefficients. And then what is the 0 of x minus 2? Let's make the note here. Note 2 is 0 of x minus 2. So that's what we put here. 2 is the 0 of x minus 2. And the order is like this. We copy the first number, we bring down 1, then we multiply 1 times 2, which is 2, plus 4 is 6. So here's my work here. 1 times 2 plus 4, and that's how we get 6. Then we multiply 2 times 6 minus 5. 12 minus 5, we get 7 here. And then multiply 2 times 7 minus 14, which is 0. So this is our remainder. This is our remainder. And so we're going to leave 7. This is our constant. We're going to attach x to 6 and x squared. And if there are more number, we go x to the third and so on. So the quotient from this division, the quotient is x squared plus 6x plus 7, which is the same thing we got using the long division. Another example. We're dividing 5x to the third minus 2x squared plus 1 by x minus 3. So we're going to do the long division first. 5x to the third minus 2x squared. You notice there's no x, so missing term, leave space, plus 1, dividing by x minus 3. So what times x is 5x to the third? 5x squared. Multiply, and we get 5x to the third. The first terms always should be the same. That's how we make it, so it cancels. And then minus 15x squared, we're subtracting. So I have to be careful when we subtract, the first cancel, but here the negative becomes positive. So that'll be 13x squared, and then plus 1. What times x is 13x squared plus 13x? I should do that in red. Plus 13x. Multiply 13x times x, 13x squared, minus 13 times 3 is 39x. We're subtracting, the first one cancel, negative becomes positive. So 39x plus 1, last step. What should we multiply x to get 39x? Of course, 39. And 39 times x is 39x. 39 times negative 3 is negative 117. We're subtracting. So the first one cancel, and we have 118, which is our remainder. Okay, we can do the same division using synthetic division. So this is long division, and now synthetic. The same problem. So we're lining up all the coefficients, and they are 5, negative 2. We have a missing, so we're going to put a 0, and the constant in 1. The 0 of x minus 3 is 3. So we copy the first number, multiply 15 minus 2 is 13. 13 times 3 is 39, plus 0 is 39. And 39 times 3 is 117 plus 1, 118. So the same coefficient, this is the remainder, this is the constant. We attach x here and x squared. So the quotient from the synthetic division is the same as before. 5x squared plus 13x plus 39. Now, I want to make a note here. Our polynomial p of x that we are dividing was 5x to the third minus 2x squared plus 1. We're dividing by x minus 3. If I calculate what's p of 3, we have 5 times 3 to the third minus 2 times 3 squared plus 1, which is 5 times 27 minus 18 plus 1, and that's 118. So it's not an accident that p of 3 is equal to 118, which is our remainder. So this is our remainder theorem, which we're going to state in a little bit. Another example, x to the third plus 8 divided by x plus 2. So let's do synthetic division. It's a lot faster, right? The coefficient 1, missing x squared, and missing x, and constant 8. The 0 of x plus 2 is negative 2. We copy the first number 1. Multiply 1 times negative 2 plus 0, it's negative 2. Negative 2 times negative 2 is 4, plus 0 is 4. 4 times negative 2 is negative 8, plus 8 is 0. So this is our remainder, constant term, x and x squared. So the quotient right here, we can write it down, is x squared minus 2x plus 4. So we had remainder 0. So note, let's make a note. The remainder is 0. So x plus 2 is a factor of the given polynomial. Okay. And last example, divide 4x to the third plus 2x minus 3 divided by x minus 3. We're going to do synthetic division. Coefficients are 4. There is no x squared, so 0, 2, and negative 3. The 0 of x minus 3 is 3, so we copy the first number 4, multiply 12. 12 times 3 is 36, 38. 38 times 3, 3 times 8, 24, and 2, 1, 14. Minus 3 will be 111. So this is the remainder. And if we calculate if a polynomial is the given polynomial, if a polynomial is 4x to the third plus 2x minus 3, and if you plug in 3 for x, p of 3, you'll see that that is exactly the remainder equals the remainder. And finally, let's state the remainder theorem. The remainder theorem says if p is a polynomial and c is a real number, when p of x is divided by x minus c, when p of x is divided by x minus c, the remainder R is p of c. And that's exactly what we noted here in the last example. And the factor theorem. P is a polynomial, and c is a real number. C is a 0 of p if and only if p minus c is a factor of the polynomial p of x. And that concludes the lecture for 3.2.